Okay, so based on that previous screen where we've seen that the mass number of an atom, all right, is protons plus neutrons. Well, a proton is one entire entity, and the neutron is an entire entity, and they've both been arbitrarily assigned the atomic mass value of 1. Why is it that the mass, let's say, of carbon on the periodic table isn't 12 if there are 12 protons, or sorry, 6 protons and 6 neutrons? Okay, where do we get the 0.01? All right, so here's just a representative box of a periodic table. Okay, isotopes, different masses for the same element. 99% of all carbon in the universe has a mass of 12. 1%, or it's slightly less than 1% of all of the carbon has a mass of 13. Okay, a very small fraction has a mass of 14. All right. The relative atomic mass found on the periodic table is actually a weighted average of the two isotopes. Okay, and here's what we mean by that. Consider the data I present here. Calculate relative atomic mass. Here are the two isotopes of chlorine. Okay, chlorine has a very nice isotopic abundance distribution. It's essentially 75% chlorine 35, 25% chlorine 37. What that means, as shown here in the table, is that 75.8% of all of the chlorine in the universe has a mass of 34.969 atomic mass units, while 24.2% has a mass of 36.966 atomic mass units. Okay, how do we find what is the mass that is displayed on the periodic table? I actually have to average them. All right, so what I'm going to do is I'm going to take the mass of 1, and I'm going to times it by the abundance of isotope 1. Then I'm going to add that to the mass of isotope 2. I'm going to multiply that by the abundance of isotope 2. That gives me the relative mass. Okay, now I should note also on here that this is the abundance. Okay, this is a decimal. Okay, to get a decimal from a percentage, all right, I'm going to take 75.8 divided by 100 equals, make sure that I can show you the decimal there. All right, .758. All right. So let's carry out this calculation. I'm going to take the mass, which in this case is 34.969 times 0.758. I'm going to add that to 36.966, and I'm going to add that to 0.242. Okay, do not forget your order of operations. Okay, carry out the multiplication of both of those before you handle the addition, and what you're going to come away with is 35.45. Have a look at your periodic table. What is the mass displayed for chlorine? Okay, so calculating relative atomic mass, that's actually based on how much of each isotope is present in the universe. Okay, so it's impossible for for us, if I just go take a sample of chlorine that I would buy, unless it's been isotopically purified, 75.8% of it is mass 35, 24.2 is mass 37. Okay, so when I go to carry out any calculations involving chlorine, I use 35.45 in my calculations. Let's say if I'm trying to figure out the mass of a compound, because that takes into account the distribution of the various isotopes. Okay. What if we ask this question the other way around? Gallium has two naturally occurring isotopes. Gallium-69 has a relative isotopic mass of 68.93. Gallium-71 has a relative isotopic mass of 70.92. Given that the relative atomic mass of gallium is 69.72, determine the percentage abundance of each isotope. So now, I'm going backwards. In the gallium question, you're being asked to find this column, all right, and you've actually been given this value. Take a moment, try to use this formula, all right, to solve for the abundances. Okay, the hint for the abundance is that, remember, what is percent based off of?